Welcome, everybody, to the Oregon Water Policy and Innovation Service, an introduction into our new memo on data centers and water. I'll hand it to you, Peter.
Thank you. Hello, everyone, and welcome again. This video introduces the Oregon Water Policy and Innovation Service and its second analysis. This one exploring how data centers use water, and more specifically, some of the policy options states are considering around data centers, along with how data centers fit in with some of the existing Oregon policies for managing water. The full report and a summary for decision makers can be found on the service's website. These are initial findings, not recommendations, and we welcome feedback. Okay. The Oregon Water Policy and Innovation Service is a joint project of Portland State University, Eastern Oregon University, Oregon State University, and Southern Oregon University to provide objective third-party analysis of Oregon's toughest water policy challenges. Okay. The service responds to asks from two or more water leaders who share a concern for the same water problem, but see policy differently. In this case, the service was asked by the Governor's Data Center Advisory Committee, which includes a diversity of perspectives around data centers, to look at one, a conceptual framework for water inputs to data centers, both directly for cooling and indirectly via their sources of energy, water outputs via industrial wastewater, and community use related benefits through things like investments in water supplies, infrastructure, and other actions that benefit the communities where data centers are located. And two, policy options for managing data center water, gathered from similar state and local policies used for data centers and other large-scale industrial users. In Oregon, there are anywhere from 123 to 136 data centers currently operational. Oregon data centers have 37 different operators, and Amazon Web Services operates 47 facilities. The Google facility in the Dalles is the largest at 80 megawatts and 290,000 square feet. Most of the data center facilities are located in the Portland metro area, with other concentrations in the Boardman, Umatilla, Hermiston area and Prineville area. Rohan?
Thank you, Peter. I'll go over a brief overview of data centers. Not all data centers are the same, and some key differences affect their water footprint. For example, the size of the data center, which may be the number of servers installed or the amount of energy it draws, or even in terms of on-site water usage at data centers, where it's used to cool servers. So how many servers, how efficiently they run, when they're used, the cooling technology they use, and the source of the cooling water all determine how much on-site water data centers use. Indirectly, in terms of offsite usage, data centers also consume water because they use a lot of energy, and producing that energy takes water, regardless of whether it's hydropower, coal, or natural gas. Data centers primarily use potable water to cool servers in their facilities. Some data centers in other states are recycling wastewater from nearby wastewater treatment plants. Data centers may use water-cooled chillers with evaporative cooling, like in this image here, which is the Google campus at the Dalles. This uses more water, but is more energy efficient than more closed-loop cooling technologies. Alternatively, data centers may also use air-cooled chillers, which uses less water, but are more energy intensive. Here is an example of a large group of air-cooled systems on a data center in Hillsboro. The air-cooled system is essentially large fans that release heat from the facility to the atmosphere, much like a home. The direct annual water use of a 4.6 million square foot data center campus with 11 buildings using 1.7 million megawatt hours per year is about equivalent to half to 1 center pivot of alfalfa growing in Central Oregon, or approximately 420 units of new housing. The most significant water footprint from data centers is tied to the sources of energy. Energy generated from hydropower, coal, and gas-fired power plants and other sources consumes water, especially thermoelectric generation that requires more cooling water. In 2023, it is estimated that power generation for data center electricity demand consumed nearly 211 billion gallons of water nationwide, based on regional energy mixes. Alternatively, direct on-site water consumption for cooling in 2023 is estimated to be 17 billion gallons, or only 8% of the total indirect and direct water consumption footprint. I'll now pass it over to Alison for going over some of the policy options they considered.
Thanks, Rohan. Our research identified 9 types of policy options. For Oregon, there were really 3 policy areas our team thought deserved the most debate and discussion, and where we could use the most feedback on the memo. Those options are highlighted in yellow on the slide. First one is siting considerations. Some cities and watersheds have enough water to support data center growth. Others don't. Cities that have unused water rights are required to have plans, but not all those plans are current. Not all cities have the capacity to get those plans updated, and not all watersheds have updated information on water availability or the water needed to keep ecosystems healthy. For example, in Minnesota, HF 16 requires review of water availability and impacts prior to construction of large data centers. In other words, good information is a good starting point. Second, and similarly, most data centers are using water from public water systems and discharging wastewater to publicly owned treatment works, i.e. cities. So cities need the tools to ensure that their water systems can grow the capacity needed to serve data centers, and that data centers are paying for that infrastructure growth. Our research found several examples where Oregon cities and data centers are working together in innovative ways to improve infrastructure, not just for data centers, but also for residents, farms, and the environment. And if HF 2261 passes in Iowa, utilities would have the authority to assign different rate schedules for facilities using more than 20 megawatts of energy. In another national example, Payne County, Oklahoma, passed a resolution encouraging the state legislature to require performance bonds to cover the costs of decommissioning data centers if needed. Third, data centers can provide an important economic development opportunity for communities. For example, data centers provide about $26 in tax revenue for every $1 in public service provided to those centers. But there are ways to ensure that those community benefits are realized. Our research points to states that are setting expectations around community benefit agreements and some examples of community benefit arrangements in Oregon. For example, the Alliance for the Great Lakes produced a guide that includes some options for community benefit agreements with data centers and case studies from Lancaster, Pennsylvania, Detroit and Southeast Michigan, the Chicago metropolitan region in Illinois, and urban areas in Ohio and Wisconsin. So that is our presentation for today. We would love your feedback by May 22nd. And you can provide feedback by clicking on the link at the bottom of this slide. There's also a Google form on the website where you're most likely viewing this video. Once we get your feedback, we'll use that to release an updated version of the memo in early June 2026. Thank you again for being here, and please don't hesitate to reach out with any questions. If you have a policy problem that you and someone who doesn't agree with you want the Water Policy Service to look into, please reach out. We're here. Thanks again and have a great day.